Good morning, everyone, and welcome to today's workshop on forest monitoring for the Copernicus WEkEO service. So my name is Gail Enavsterbik, and I'm a training officer at Mercator Ocean International, and I'll be your host for today. So we will have a two-day workshop, and today we will have more of an introductory session where we'll tell you about what the WEkEO service is about and what sort of data and products you can find and what sort of application you can do with the data we provide to you. So before we start, we are going to go through some house rules and guidelines to help you follow this workshop in the best possible ways. So first, you need to access the audio logo on your bottom left part of the screen if you want to be able to hear us correctly. And also, we ask you not to use the chat that you see on your right side and for the question. You can use it for small talk or say hello to us or talk between each other. But if you have more of a technical question, especially regarding the presentation, we will ask you to use the Q&A section. So you might find it there. So on the top bar of the page event, there is a section dedicated to the Q&A. So that's where you can ask the question to the speaker today. So speaking of our speakers today, we will have many interesting presentations. So first, we will have an introduction to the WEkEO service. So I will give it to you. And then we will have a project overview by Christian Florindo from Lobelia Earth. And after that, we will have 3 use cases. So we will have, so the first one will be Rowan Philly and Tim McCarthy from the Maynooth University. Then we will have Mikko Stralendorf from the Finnish Meteorological Institute. And finally, we will have a presentation from Gerardo Cerecci from the University of Florence. So it promises to be a very interesting morning, and I hope you enjoy it. So first, I'm going to do the WEkEO introduction, as I said. So, So what is the Copernicus WEkEO service? So WEkEO is a DIAS or Data and Information Access Service. So it was basically created to facilitate the access to Copernicus and Sentinel environmental data in WEkEO. And it's a program funded by the European Union. What we offer in WEkEO is, as I said, you can see an easier access to environmental data, but also cloud infrastructure and a very competent user support. So if you have any question, you can contact them. So WEkEO, as I said, is operated by the different entities that are entitled to manage the different Copernicus services. So if you haven't heard of Copernicus, it's a European Union program dedicated to Earth observation and to monitor the Earth. So we have different entities that are responsible for the different services. We have Mercator Océan, ECMWF, EUMETSAT, and EEA, sorry. So the services are the following. You have the land monitoring services, the climate change monitoring services, the emergency monitoring and security services, the atmosphere monitoring, and the Copernicus Marine Service, finally. Besides that, we also have Sentinel missions, which are the satellites that provide the data that you can find in Copernicus, and they also have some missions, which data you can also find in WEkEO. So, how you can access WEkEO. So you can go through its website. So you will be able to find the catalog with all of the products. You will find more information on like computing resources. You can find use cases. You can also access the different events that we organize and many other materials. And also 3 main assets from WEkEO. So, and why it is an advantage is that it provides direct access to Copernicus service data, which is directly linked to the original sources. So it is not a copy. And this access is also harmonized. So that means that facilitates some programming and an analysis that you might need to do with the data. So besides that, there's also, as I said, a very active user support, so which you can always contact and ask any questions you have related to the data or how to access the data. So, and as for any of the Copernicus data, the access to WEkEO is free, and the access to download the data is also free of charge. So it's an open source data, environmental data, which we provide. We also provide free access to e-learnings materials, which are, for example, Jupyter notebooks. And then we provide also a section that, for example, if you are more experienced and if you would like to have some computing power, that is part of what we apply cost. But for the rest, if you just want to visualize or access the data, it remains free and open to everyone. You can also have an access to a Jupyter Lab. So if you have heard of Jupyter Notebook, this is a nice way for you to learn how to use the data and how to do basic analysis and kind of track your evolution, because we share it through its Jupyter environment and you can learn a lot through its platform. And so speaking of Jupyter Notebook and Jupyter Hub, so here we have the Jupyter Notebook gallery, where you will find a lot of notebooks already developed on different services. So you have notebooks for climate, atmosphere, for marines. You have everything you need with different filters to help you find what you want. And you will also have access to virtual machines. So I will not go too much into that today, but don't hesitate if you have any question about this virtual machine to contact the user support. And so speaking of the user support, it's easy to contact them, so you can do it by email or through the help center that you will find on the website. So you also have a section dedicated to usually current question, so you might find your answer even before contacting the user support. So that's all for me for today. I hope you got a little glimpse of what the service is about. And now we will dive a little bit more into the products itself. So it will be Christian who will do the presentation. So whenever you want, Christian, the floor is yours.
Thank you very much, Kyle, and good day, everyone. Thanks for the introduction. My name is Christian, and I'm currently acting as the WEkEO Data Portfolio Manager. And in my role, basically, I just overlook that what is the catalog offer, that everything is in place, and the things are that we can update about changes in that catalog. So I have an overview that I wanted to share with you as well. I wanted to share with you some highlights about the type of products that you can find in WEkEO, and then focusing more, of course, in the forest monitoring. Currently on WEkEO, you can find more than 450 different data sets, covering all the different Copernicus services, as well as Sentinel missions. And so just as at a glance, the different services, what they provide. So starting with the Copernicus Land and Monitoring Service, which is the most relevant for this topic. It provides from global data sets, but has a particular focus on pan-European data sets covering land and its monitoring, not just the EU or Europe, but also other collaborating countries and also territories beyond sea. It also has some data sets that are local because of interest, like the Natura Network 2000, and so on. But we'll look a bit more into the different data sets in a couple of slides. Then we've got the Copernicus Marine Environment Monitoring Service, which has a full range of variables and data sets covering all aspects of the ocean, from blue ocean, more on the physics, like temperatures, currents, ocean circulation, but also on the green ocean, or anything to do in biogeochemistry, primary production, oxygen, nutrients, etc. And of course, the white ocean, or anything to do with the cryosphere and sea ice and snow. So you will find data that comes from models, but also from observations and large observing programs, and in situ data as well. Yes. So in the Copernicus Atmosphere Monitoring Service, you'll find also again a few data sets covering the composition of the atmosphere and covering from, well, usually global, but you can also find some regional data sets as well. And you will find also a lot of variables that are used in forcing models as well, and different forcings, and data on analysis, pre-analysis, forecast, and products as well on air quality. So it's a full range as well, but of course it's more focused on the gas composition of the atmosphere. Then we also have the Copernicus Climate Change Service, which is it contains a lot, many data sets related to climate change, combining a range of in situ observations, satellite information, model data to provide products and variables that are often used to understand, monitor, and project changes in our climate. And then finally, we also have some data sets from the Copernicus Emergency Management Service, mostly related to floods and flood information. And then again, the different data from the different Sentinel missions with different levels of processing. Now that was a sort of an overview of the different services and a few of the products that we find, but now we're going to talk a bit more about those products from the land monitoring service that have been provided kindly by EEA. Again, I'm not an expert on forest monitoring, but I can give you a highlight as well of the main products that are related to this topic. So starting with the high resolution layer, is one of the most important. You will find information about tree cover and forest. And then it's an essential tool to understand, forest dynamics across Europe. So the first one, the first variable or information that you can find is the tree cover density, which gives a detailed canopy density measurement, going from 0 to 100 of cover. And it has a 10-meter spatial resolution, and it covers the EEA 38, which is the countries covering the EEA, but also a few participating countries in the Copernicus Land Monitoring Service. So it is updated regularly, and it has over 90% of accuracy. The resolution, oh sorry, the temporal resolution is annual. Next, we've got the dominant leaf type, which is a classification between coniferous or broadleaf, usually. It offers the same resolution, 10 meters, and annual. And finally, you can also find the forest type, which is that difference classification between coniferous and broadleaf, but also specifying the type of forest following the FAO forest definition. And it has some filtering to do with the tree cover density and a minimum mapping unit of 0.5 hectares. It also includes trees in urban and agricultural settings. And the resolution is 10 meters, but also it's less frequent, so every 3 years. Another interesting layer that you can find in this service. Sorry, before we move on, this is an example of saying automatically. Okay, so I'm going to do that. Okay, here we go. Oops. Sorry, there's a small delay. That was an animation that compares these variables, the tree cover density and the dominant leaf type, comparing 2 years, 2018 to 2021. In the animation in the center, you can see how it's changing year to year. This is a good example of how tree cover density can be used, for instance, to assess deforestation or even line cover change. So you can see that sort of how it drastically changes in that particular parcel uh, from one year to the other. The next data set that we will be talking about, and there's a small delay, here we go, is the high resolution layer for vegetation phenology and productivity, spanning from 2017 since 2023, but there's also some information from 2024, I believe, already. Yes, because it's near real time. So the resolution is 10 meters, and you will find information on phenology and productivity, which is crucial for insights into vegetation health and productivity. Um, so again, 10 meters resolution with phenology that helps us observe vegetation growth cycles and how they change over time. And it is near real time. So that's really important for monitoring. When we talk about near real time in WEkEO, it's basically daily products usually, or sometimes hourly, but in this case is daily, and it is provided just a few 1 or 2 days or just a few days after it is obtained. And that's why it's also near real time. And there's future prospects to develop, which are disturbances, both biotic, abiotic, anthropogenic, and biomass productivity in gross and net productivity. And finally, we've got small woody and landscape features layer, which is a data set on components of landscape connectivity and ecological networks. So this layer is very high resolution. So it has a 5-meter resolution, but is updated every 3 years. And it gives information about what it maps small woody features, such as hedgerows, isolated trees, patches of shrubs, etc., which are crucial again for biodiversity and connectivity to larger habitats, and also for ecosystem resilience and biodiversity conservation. And with that, I will be finishing. This is a summary table provided by EEA about the different indicators, forest connectivity type, tree cover density, forest area, etc., and a summary of the resolution. So again, that's a bit of an overview of what we can find on WEkEO, especially for forest monitoring. And thank you very much. And if you have any questions, I'll be happy to answer.
Thank you very much, Christian, for your nice presentation. So right now we don't have any question, I think. We will wait like 30 seconds to see if something comes, but it was a really clear presentation. So
Thank you. Again, I'm not an expert on forest monitoring, and I'm sure my colleagues here will give very nice presentations that will be a lot more informative about the use of these data sets as well. If there's also any questions about WEkEO as a whole, yeah, I'd be happy to answer.
Yeah, so yeah, right now if you have questions, it's for the products mainly in general, but the expert on forest will come right after. But yeah, no, so I don't see any question coming. So let me check. I will look in the chat. But So yeah, just I see one question in the chat about the availability of the data. So you have data all around the globe and in Europe, so you can find everything you need. And also for the more general question about certificate, replays, and presentation, after the second day, so Friday, you will receive by email a certificate of participation. And like 1 week after the event, you will also receive an email with the links to the PDF presentation and the replays of the event if you want to watch again, or if you need the presentation and if you find some slides interesting. But yeah, I think we will move on to the next. Oh wait, is this software free? So we have a question. Is this software free? So yes, so you can access and download the data for free. So and yeah, that's it. After, if you want to use Python or MATLAB or QGIS to look at the data, you are free to do so. So okay. So oh yeah, so now we have lots of more, plenty of questions coming. So what is the difference when I use the Copernicus data on my own versus via WEkEO? So actually it's the same data, but I will leave Christian speak more about it if he wants.
Yeah, so yeah, the source data is the same, actually it's stored in the same place. So the difference, well, in WEkEO, it's in the platform, you can explore the data in a very quick way, really accessible. You can navigate between different times and space, and the loading of data is really fast. So it's really easy to explore it and then select specific areas that you may want to download. And besides that sort of data viewer, you've got also other benefits of using WEkEO in terms of cloud computing, etc., and notebooks that facilitate the processing and the download of data.
Yeah, okay. So this question that we more or less already answered. So yes, you have forest data all around the globe, obviously where there is forest, but yeah, you can find everything you need on the catalog.
Yeah. And it's just to say the data sets that we talked about, which are provided by EEA, are European initiatives. So most of them are European cover, but there's some global products on WEkEO on this topic as well.
Yeah. Are there any plans to include data on historic wildfires and wildfire risk? So if I'm not mistaken, we have data on the wildfires.
Yes, this is correct. There's a few data sets. I think they are allocated in the Copernicus climate change service, which historical wildfires and many other variables on this topic.
Okay. Can I use the data, I guess, without downloading the data? So actually, on Friday, we will have a demonstration of the WEkEO viewer. So I invite you to connect on the second day. You will see how you can visualize the data without downloading it. So it's a really nice, it will be a really nice presentation. So yes.
I recommend it. I recommend it because the viewer works really well and it's really convenient to explore the data before you even download it.
Yeah. So is this available for smaller companies working on marine and land agroforestry service, and what are the costs? So yes, Christian, you can go if you want.
Yeah, the access of the data is free. In terms of licensing, I'm not sure if there's any specific license, but I think it's free to use.
Yeah, you can use the data freely. And it's also linked to the next question about the computing power. So just running a Jupyter notebooks mean computing. Could you specify whether we can use algorithm on the available data? So when I said the WEkEO computer power is you need to pay, so it's not all of the computing power. So I don't have the detail here in my presentation, but if you look at on the website, you can have like a lot more of CPU to run your codes and scripts and stuff like that, but depending on the capacity of the CPU and storage you will use, you will need to pay not a membership, but you will need to pay a little bit money to use this computer power. But usually the basic one is more than enough if it's just for small data and stuff like that. Okay.
As a user, I've never had to use the additional capabilities. So for regular operations, it's the free service. It's more than enough. Yes, I agree.
Oops. Yeah. Lots of questions coming, so we will have to stop at 30, but we will try to answer as much as possible. So, is geospatial data will be available to us, or can we download it for free? So
yeah. So again, what you see on WEkEO is free to access, free to use, free to download.
Okay. All the data free for download, even all the data are free to download, even the high resolution one. So all of the catalog is free to view and download. Yes, so you can download anything for free. Is
right.
the
Sorry.
Yeah, sorry. Is the data set available monthly with same accuracy? So
right. So depends on the data set. Some of them are annual, the other ones are near real time. And I would think, I mean, in terms of accuracy, yes, it is true that some products are processed later when they are not near real time. Sometimes some products have additional processing, but in terms of the resolution and in general, the accuracy should be the same if it's provided at that resolution. Not all products are provided at monthly resolution or even day.
Yeah, okay. Okay, thanks. So we will do 2 more questions and then we will have to move on. But for all of the unanswered questions after the event, we try to do a post-event report when we answer all of the unanswered questions to make it available for you. So no worries about that. Are there any delays when downloading the data? For example, for the LMS, you need to wait before the download is ready for some of its products. So yeah, if it's wait to the download to be complete, yeah. I don't know if I understand.
And then the same with WEkEO, when you select an area or a download, it needs to be prepared. It's in the backend. So there's sometimes a small delay, but you can track it. You can see how long that is, and it's not a big delay. Yeah. Unless, I suppose, if you're trying to download a massive amount of data, that's I guess the larger the data set, the longer it takes to be prepared. And then once it's prepared, you can see as a job in WEkEO, then you can download that job.
Yeah. And finally, so it will be the last question. Are there plans to integrate the data available on WEkEO in the Copernicus data space ecosystem, which we use for Sentinel-2 data download and processing? I don't know about that. I don't know if you know. Okay, so we will.
No, I'm not familiar about the Copernicus planning.
I think we have one of the use case that might have the answer. So Miko, if you want to take the lead on this question, you're welcome.
Yeah, thank you. This is more a question that I'm also the Finnish delegate to the Copernicus committee, where we, of course, kind of manage in a way the top level of these things. So in essence, I think WEkEO products could end up in the Copernicus data space ecosystem, and vice versa. Like Copernicus data space ecosystem material could be in WEkEO, and they try not to be kind of for real like in 2 different places, but it's more like that the APIs are actually such that from different places you get to different places, but both of these are still also evolving and not just static. So that's why I would say at this moment, most of the like direct Sentinel data, it's the Copernicus data space ecosystem. And then when you come to the services and the like higher level like value-added products, there you go to the WEkEO. That's the simplest answer for this.
Okay, thanks for the explanation. So thank you very much for taking the lead on this one. So thanks for all your questions. We will have to move on to the next presentation. Thanks again, Christian, for your presentation and the question. And yes, I guess Rowan, you're next, and see you soon, Christian.
Thank you. Bye-bye.
Thank you, Gaela. So Tim and I are going to try and do some Zoom tennis during the presentation. Tim, if you're able to jump on, just let me know.
Yeah, and I'm just doing a
perfect.
quick voice check there, Ro, just to make sure it's all working.
Brilliant.
Good. Okay.
Okay. So just over the next 10 or 15 minutes, we're just going to give you kind of a brief overview of Terrain AI, which is a project Tim and I have been leading out of Ireland over the past number of years. And in terms of the kind of research infrastructure that we've developed to support research. We take a slightly broader definition of research infrastructure beyond that of kind of the EU definition. And we make the case that research infrastructure should also include the activities in terms of the data collection activities, but also the workflows. And I think Gael and others have previously mentioned this around the Jupyter notebooks. So just by way of introduction to what the project was, it was funded by a national funding agency, National Science Foundation Ireland, and Microsoft. It was a €5 million project led out of Maynooth by Tim and myself and partnered up with a number of research agencies and institutions across Ireland. And ultimately, this the graphic on the right kind of is a simplified kind of representation of what we were doing here. We effectively were trying to build a framework for integrating spatial, temporal, thematic, multimodal, multi-thematic data and measurements across diverse land cover types and uses, ultimately with the aim of improving our understanding of how human activities interact with land management, but specifically around looking at emissions and sequestration potential. We were looking at all terrestrial types in an integrated manner, so looking at urban, grasslands, peatlands, croplands, but also forestry. In terms of trying to do that, it's actually quite challenging. It's much easier to talk about. And the challenge really is actually in how do we bring together the disparate data sets that are required in order to inform how we understand or improve our understanding around these different land cover types. There's various data, and the x-axis here varies across spatial scales, but we also have data varying in terms of the temporal scale. So we might have very high resolution 10 Hertz flux data measuring CO2 emissions coming off the landscape. We also need to understand the phenology of what's been grown in a particular patch of the landscape, but we also need to understand the management. So ultimately what we're trying to do is move from the left side of this diagram where we have lots of these different data points and start to move towards the right of the diagram where we can start to support regional, national, but also international policies, specifically around carbon reporting. So the nexus point that we were trying to chase ultimately was, could we develop more transparent, robust, scalable data, methods, and models that could ultimately inform improved land use management, but also reporting around emissions and so forth. Tim, do you want to?
Yeah, sure. So I guess here, like we're just looking at different kind of data inputs, and we cover the full stack from like satellite through to airborne, drone, and then down on the ground in situ. And then we contextualize that then with different data sets coming in from the geospatial side. A big part of this is the stakeholder engagement piece, and it's something just worth keeping an eye on with any of these projects. You can't do it alone. So it's really good to reach out and have connections to the likes of Copernicus and the European front, different kind of relevant say agencies there, right down into your local kind of member state organizations. And so we worked with quite a few, I guess. Rowan, back to you.
Yeah. Yeah, and I suppose, look, one of the challenges we encountered here is that actually when you try and collect and collate all this disparate data sources, it's distributed across multiple different agencies, as Tim has just alluded to. So, for example, if you're looking for satellite data, you may have to go to ESA, NASA, or Microsoft Planetary Computer. If you're looking for climate data, you may need to go to Copernicus or ECMWF. If they're national data sets, you need to understand the national data holder, right down to individuals. So what we found actually was that environmental data required to address some of the big 21st century grand challenges around climate change and biodiversity loss are incredibly fragmented. It's also compounded by the fact that there's an absence of a data catalog with appropriate metadata, and also the ability to compute this data. So, for example, us as researchers, do we need to be experts in processing satellite data and complex NetCDF climate information? So the point here is that researchers spend a lot of time actually just chasing data and processing the data before getting on with the actual job of doing research. Tim.
Okay, and I'm just looking at the time here. We got 15 minutes odd left, I think. So, look, folks, what we've done here is we've focused in on the Open Data Cube. We've implemented that on Azure architecture. And you'll see there from left to right the flow of data, which is collected from different Earth observation platforms, both remote sensing and then on the ground in situ. We use the data cube quite a lot here to be able to kind of, work at kind of national, regional scale, but also to go down to that kind of plot level when we're talking about like forestry, fields if it's farms. And you'll see there that we bring in ML here. Again, it's nothing fancy, but just to assist us in both the analysis and also working into those kind of higher level modeling pieces. And well, I'll hand back to you there, Rowan, on that one.
Yeah, so we just take a couple of examples for each of those just to demonstrate what we're talking about. So on the left was the benchmark sites. We're working with various research partners and institutions across Ireland that have deployed flux towers. These are the eddy covariance systems that measure CO2 across the landscape. These dots in a map represent the different locations. The different colors are the different land cover types. And you can see two forestry sites there located in the centre of Ireland. We're now at the point where Ireland has one of the densest flux networks globally, in fact. And as part of Terrain AI, we deployed two forestry sites. You'll see the pictures in the middle here. Colga on the top in January 23, which is a 15-meter tower over mixed species on peatland, and Ballykilcavan at the bottom there was a 45-meter tower over broadleaf forest. And again, this was to augment the existing long-term monitoring site at Dury coniferous forest to try and establish long-term research capacity in forestry across Ireland.
Can I jump in there to Rowan and just say that the importance of benchmark sites, they do two things. They give you like the training data. So remember what we're doing here. See, Ireland is a laggard in terms of forestry. We're about 11% coverage in Europe, and I think about 2% of that native species. We're really, really poor when it comes to like forestry. But these benchmark sites give us that training data and representative, mix of species. The second thing to do is quality control, so that when we take those models and we build and test them, we can come back and actually just prove that we're doing the right thing. So we hold back different test points in there. And just to kind of colorize that a bit, we have both sensors at these sites and we carry out surveys at these sites. So we will do soil sampling in these forest stands. We will do overflights with, say, a LiDAR and look at DBH stuff with GeoSlam and so on. Back to you, Ron.
Thanks, Steve. So this is just an example of one of those forestry sites in Colga, which we deployed almost 2 years ago now. It's a mixed plantation over peatland. And again, on the bottom right here, it's not just a flux tower. As Tim has said, we go out and do very detailed site surveys in terms of the surface, litter fall and so forth, subsurface in terms of soil moisture, but also right up through the full data stack, right up into the atmosphere using drones, aerials and satellite information. Bringing together this network so that it's coherent and integrated, we've spent quite a lot of time in terms of trying to coordinate these different networks. And we've developed a suite of protocols. These are similar to the ICAS protocols, but much more detailed in terms of how we develop the footprint analysis, the vegetation monitoring that we undertake, but also the soil surveys here in the bottom right in terms of the soil heterogeneity and how that might partly explain the measurements we're obtaining at these sites.
So like, and I guess, Rowan, it's important to say that we're not just looking at the kind of static kind of inventory, above ground biomass aspect, but also what's key here is getting a better understanding on the greenhouse gas fluxes. And so there's both static and dynamic things going on, and we're trying to have a go here at building a platform that can come into forestry and just take a look at all of those kind of facets, Rowan. Yeah.
Absolutely. So we're ultimately trying to link the measurements from that eddy covariance tower back to the underlying footprint, which has phenology changing, which is management practices changing, but also sitting on more static kind of type data sets in terms of the soil texture and so forth. Yeah.
Okay, so just very, very quickly, I'm just watching the time here. So we're just looking at satellites. You'll all be aware of those. We are looking forward to like the new satellites coming down the line, like Roselle in 2028, looking at the L-band canopy penetration. We, of course, will use the classic kind of stack from Sentinel and Landsat here. And of course, keeping an eye on the new kind of X-band stuff that has appeared more recently on Brass, Capella, and of course the older Terasar X. These are all key to kind of give us a hand to collect that information. Go back to what we were saying before. The idea is to get these benchmark sites and then to kind of build these kind of models that can be expanded over other areas, keeping in mind the soil, building it right up through to the species, the different plots. And one important thing that we didn't mention with the actual sites is the management activity. So we're having information from the forestry companies and organizations on thinning programs and clear cuts and so on. So here, of course, we have our own aircraft with our own sensor pod, and we deploy different LiDAR systems. We've got Regal Vux 1, where we've got a 240 coming online soon. Switching to drone, then, of course, we've got the old Zemus from DJI and the Yellow Scan. And you'll see that we also have the AFX hyper spectral. So these are just all the tools of the trade. We can keep going there. And what's important, and Rowan alluded to this, is building this metadata, data catalog. So we don't really care who owns the data. Don't get proud or don't be, that's not really important. Leave the data sit where it sits. The important thing here is the catalog, the Rolodex card that points to where that data is, how you can access it, and any licensing information. That's what's important. So what we've done here is complete the data catalog on all EO, GIS management data. That's all Inspire compliant. Next slide. Yeah, and you'll see here how we can kind of switch from static data, if you like LiDAR, to very quickly. I guess Rowan, the more dynamic real-time flux data coming out of Colga and so on. Yeah.
Yeah. Again, this is about the data standards, Tim. In terms of a lot of the flux instrumentation is still relatively new. We don't have similar standards to meteorological stations established like the WMO, and it's really important that we understand the instrumentation type and so forth as part of the processing of this data. So it's again about establishing that integrated but also standardized network of instrumentation suitable for addressing the questions we're asking.
Yeah, and we can keep going there because I'm just watching the time.
Yeah. So again, just working through. It's not just the meter.
So again, like these are as Rowan's flicking through.
Yeah.
Yeah, no, and as Rowan was alluding there too. So we have this platform, and the nice bit about it, I guess, is the visualization. So we're able to go and look at a site, and you'd see there the way we kind of approach this from a regional scale, then come down into more, compact AOI to where we're dealing with, say, like a forest stand, and then within the forest stand, then we will be dealing with actual subplots, and we will have all those catalogued, if you like. So it allows both the researchers and indeed some of the stakeholders we're working with to quickly drill down and first of all to discover data. Secondly, look at some of the analysis, and then be able. We don't want to hold this back under our own kind of coat, but leave them work with. This is a very open access platform, I guess, Rowan. And the Jupyter notebooks, this is quite key. So instead of us repeating the same old mistakes, I know a lot of the folk, it will resonate on this workshop call. What we try and do is like standardize those Jupyter notebooks. For us, the catalog is actually a digital catalog. So it's not just data, but it's also those workflows, those processes, those modules, sometimes encapsulated in a Jupyter notebook that can be used and reused, adapted, configured, and brought through. Back to you, Ron.
Yeah, so as part of that, having brought all the data together in a centralized point of access, as Tim is saying, we can now do interesting stuff and develop those automated workflows in terms of the Jupyter notebooks, but also in terms of data fusion, in this case around Sentinel-2 and drone data. This was a particular workflow that we developed to try and detect the management. Management is fundamental in understanding the emission response at a particular location. So we've been trying to develop these automated or semi-automated tools that we can almost remotely detect the significant management events. This is a grassland in the southeast of Ireland. So we've grazing practices. Can we visually see where, you know, grazing has occurred? And that's important in terms of if you're to run a crop phenology model, a grass growth model, but also to understand what's happening in terms of the dry matter and the response of the landscape to a management change. This is
So like,
yeah. Go ahead, Tim.
And I guess inside here you'll see just different aspects. Myself and Rowan will come clean. We're not foresters. We're kind of computational people, Earth observation people, modelers. And in here you'll see the GCBM being used. But the key thing here is us setting the scene, providing the platform, collating the data, making it discoverable, having the basic analysis tools all encapsulated in Jupyter notebooks to us to drill into kind of like forestry. So we're not just looking at what's going on with the soil. Remember, here in Ireland, a lot of the coniferous forestry is associated with kind of organic soils, peaty soils, very poor soils from a farming perspective. So just saying very, very quickly, this platform, I guess, Rowan, just allows us to drill into different aspects.
And ultimately, as we moved across that original state-of-the-art diagram that Tim spoke about, is moving towards that model and scenario piece at the top of all this. So ultimately, it's about the collection, collation, standardization, and ultimately generation of analysis-ready data that we can ultimately inform improved models. And around that, we've developed an integrated modeling framework. So we have our individual domain models in terms of, you know, crop, grass growth, arable, or forestry models. We've also integrated peatland models. We also have specific process-based models around soil carbon and the more dynamical land models. But the ultimate goal here is to integrate all of those, everything that we learn from those detailed forensic level assessments at our benchmark sites, and take that and cascade that up into our coupled or integrated models. So for example, we run the WARF model out of NCAR coupled with a chemistry component, coupled with the vegetation photosynthesis respiration model. Why are we doing this? It's very simple. We can't measure every square inch of the landscape, but if we can develop and improve the models to the point that they are able to reliably estimate what's being measured at our benchmark sites, we can then roll them out across the landscape to estimate values at unmeasured locations. And you can see here in the top right of the graphic where we're using our integrated model to estimate a net ecosystem exchange at one of our benchmark sites. And the model is doing a really good job here. So it gives us confidence that we can take the learnings and transfer them to other locations. And finally, then, I suppose the end point of the discussion, to come back to where we started, it's ultimately about designing this kind of integrated research infrastructure that's more than the equipment, it's more than the compute. It's actually how you conceptualize this from your initial point of departure around these benchmark sites. How you centralize, collate, develop the standards, metadata around that information, the tool sets that you can build, having a centralized point of access to process that data, effectively to do the heavy lifting for researchers, and ultimately how this information can cascade or effectively feed into improved assessment and modeling. And that's ultimately what we're trying to get after here. How can we do this in a more integrated way? and ultimately address the types of challenges that are really important in the 21st century. So it's no longer just climate change, it's looking at climate change, biodiversity loss, and within that, forest will play a key role in terms of the sequestration potential. I think I'm just looking at the time, we might leave it at that, T.
Could I just mention just one thing, because we should have mentioned kind of this earlier, just to kind of color this a bit more. So one of the tasks that the forestry guys said to us was like, how could we make their lives easier when they go to carry out on the ground DBH kind of measurements? So we said, look, we can configure the platform. So we look at the stratification initially over the forest stand. We can do it on a landform, you know, the shape of the land, the soil. We can look at the species, look at the age, look at the management type, and have that first initial remote sensing push over those plots to try and figure out what's going on. And then what you do is that in there, you begin to pick out areas within the plots that might be vary slightly. So this is where you target that has that strategic DBH on the ground sampling. So that's an example of how we were able to use the platform to kind of, and I know this isn't new, you'll all be aware of this kind of work, but it just shows like the power of the platform to be able to kind of reduce, you know, a person days walking around the forest doing your DBH measurements. Rowan.
Yeah, no, back to Gela.
You want to take the first one, Rowan?
No, so focus on Ireland initially was just as a test case. This infrastructure is absolutely scalable across jurisdictions. The plan is that we will scale it. Ireland for us really was just, it was represented a specific domain that we could develop and test many of these ideas. So the intention is to expand, yeah.
And I guess, Rowan, as well, it's important to you know, pinpoint the ethos here. We're not into kind of keeping this behind. We have a very open access kind of push here. So you know, if folk want to get in touch with us, we'll try and accommodate there. So the idea is to have this platform as just a template. If there are useful bits to it, we will open those up to other folk. You can see there the benchmark sites. Well, I guess this is back to you, Rowan.
Yeah. So look, we anonymize the locations, randomize them in terms of to protect the equipment and so forth. But absolutely reach out to us and we can put you in contact with the site owners. And again, the whole focus of the benchmark sites is that they're not just there for collecting flux data. They become a concentrated effort for collecting lots of data, all of which benefits the site and the research activity.
I'll take the third one there, just from in terms of the recordings and data service and so on. Look, we are researchers here. We do, the way we work is that we go out, we try to get funding to do this kind of pretty kind of crucial kind of work. So we will help out as much as we can. The best thing is just get in touch with us and we can see what we can do. Currently, just to explain, TerrainAI has finished its phase 1 of the program. We're in the middle of doing some interim pieces of work with selected crowds. Like, for instance, we're working with agriculture, we're working with kind of urban and municipal planners and so on. So the best thing is just to get in touch with us and we can see what we can do.
Yeah, thank you so much. Sorry, I was pushed out of Zoom for a few seconds. So I guess you answered the first 2 questions that you see on the screen, if I'm not mistaken. Okay, thanks a lot. So, and also thanks for your presentation. So as you saw, we have several questions. I know you have to go after because you have a course to give. So maybe, okay, I have one question about really your presentation. So if you could answer this last one. So on community network of network, you use points to represent flux sites. I thought we used polygon for field data.
Yeah, the points are big fuzzy points over our locations. I'm not fully clear what's being asked here, but the flux sites are footprint based, so they're measuring across a polygon, but the site locations are fixed in space. They're a point, but I'm not fully sure. I understand
Rowan,
the question.
could I just jump in just
Yeah.
from an Earth observation point of view? That perhaps one way to look at this is that there's massive variation across the landscape, and we understand that stuff in Greece is different to stuff in Germany, different to stuff in France, Ireland, Spain, Portugal, and so on. So what we're trying to do here is to use these benchmark sites to see if we can strategically place these benchmark sites to capture that variation, build up the model then so that we can kind of, expand that across, a regional, national, provincial scale. If that makes sense. So, and again, we're working with static and dynamic inputs there. So just saying that, look, this is kind of a multiple kind of puzzle to solve here, but it's those kind of tent poles, if you like, that act as the benchmark sites, and the canopy then is that model that goes right across to tell us what's going on in places that we don't actually go out and measure.
Okay, thank you very much. So as you see, we have several other questions, but I know you have to go and we have to move on to the next presentation. So if you're okay, can I send you all of the unanswered questions to answer a little bit later? Oh, okay. So I think he left already. So Nico, so thank you very much. And whenever you want, you can share your screen and your presentation.
Yeah. So good morning to everyone, or almost midday for us in Finland. So I come from the Finnish Meteorological Institute. And in addition to being this Copernicus committee delegate, which is like high political and program, I also work at an institute that does climate services and to also have a practical view on Earth observation and all the wonderful data sets it has. I am active in doing this kind of projects, which are around a service called Harvest the Seasons. And it's good to understand that Harvest the Seasons, we started already in 2019, actually very kind of simultaneously as WEkEO became the first phase 0 available, and we really built this thing on WEkEO. So we are very grateful for WEkEO, and it helped us a lot. But this was really a Copernicus Climate Change Service use case project that we got, in which we made the first version, so it went online. And since it has been online, we have been online. But we have had 2 other projects to kind of develop us further and get us kind of keep it for free and open to anyone to use. So there was an E-Shape Horizon 2020 project where we added weather forecasting, and actually many of the Earth observation data sets that were presented before, or many, but some of them are at least also used in our service, and this is mostly because of E-Shape. And then really last year and until end of April this year, we worked in a Destination Earth project where we put some machine learning into this action as well. And so thank you for the European Union, and thank you for ECMWF as the mediator in 2 of these cases, but it's all European Union funding. So thank you very much for that. But then let's go to this use case, and we are definitely not for research. The whole point for us is actually that for research, you can just have lots and complicated and everything. But when you really go to a business case, and in this case, our key users are really those forestry operators. So when someone does harvesting and uses big machines to go into the forest, at least that's how it's done in the Nordic world. That's the way it's done in most of the places. Like the man with a chainsaw is yesterday. So these big machines can do it in winter conditions wonderfully. That's traditionally how it was done in Finland. Well, guess climate change should be something that everybody is aware of, and that's true, and it's here, and it has already happened. Because in Finland, this is the reason why the winters are too short to do forestry in the old ways. So we need to also be able to do something in summer. And these big machines in winter, the snow or the frozen soil really carries these machines so that the soil is not compacted. So it's not pressed together in this place where the machine works. But in summer, this depends only when it's really dry the soil, and then the same conditions apply. And we try to help now to find also summer cases and tell the users where are the winter cases still good. And So we have to predict three things: frozen soil and how deep it goes, and then the snow height, how much that is for the winter case, and then really soil moisture or soil wetness, however you want to call it, that we predict that particular feature for the summer case. And we really are a partnership of three different entities, where the Finnish Meteorological Institute is the main entity to run the service, let's say, run the projects and kind of, let's say, operate everything. But then we have really as a very important co-designer WEkEO. It's a Finnish company that many forestry sector companies own. So it's a development company where I think over 20 different, let's say, owners that all are either big or smaller forestry operators in Finland. And then Spatineo is a Finnish small company for geospatial data systems. So we have together built the service. But it has been really key that through WEkEO and their owners, actually, Metsä Group is a kind of medium-sized forestry operator who do everything. So they have these big, let's say, bio plants, as they call it nowadays, where the forest material is being processed into all kinds of products. But really, them being there as also owning forest for a part, but then especially doing the timber procurement and in that sense, choosing and managing where forestry happens. So they have been helping us as co-designers to get to this service that helps really this very pinpointed thing that if someone goes into the forest to do operations, that is that a good condition for doing it or not. And this is really interesting. In addition to that forestry operator, also the forest owner, of course, because he decides to sell, and when he sells, he needs to know when the forest, of course, is actually operated on. But really, this timber procurement logistics is important. And then there are lots of consultants in the game, because this is a big industry in Finland and the Nordic countries at least, and regulators are partly also interested. But on the right side, you see how the service looks like. And I think it's really important to understand that for a large part, what it means to go to a business case means that we have to really be more simple and simple in our answer of what is it and what not. But of course, we also do have this complexity, and we have tried to do this in a way that we have a simple graph on the top, which is like the graphs are high, it's good. The graphs are on the bottom, it's bad. And then you have the timeline from here to forward. We also have a map. The map is kind of messy and a lot of red when it's bad, but when it's good, it gets pretty green. That's how simply we want to do this. But the main kind of interest for us is really to do longer term forecasts, not just the weather, so not just a week ahead or so, but to go over 6 months ahead. And this is possible with this something called seasonal forecast, which is a Copernicus climate change service product. That means actually 51 different kind of weather forecast like forecasts of the next 7 months. And the system that we are doing here is really to find those thresholds that say this is good, this is bad, that we try to kind of highlight the points where 90% of these 51 forecasts for a certain point somewhere are saying it's good, it's bad, or we don't know in between, because we are not thinking that we can say everything. But this shows then to the end users where they can use planning kind of horizons. So in winter, they have to consider that, hey, we might leave this one winter patch now because we actually look forward to the next summer, and it seems there are opportunities to do this piece of forest there also in summer, and we take those forests that definitely need a winter condition and go for them in the winter season. So that's the, let's say, most use cases. And really, it's actually today being the 15th, or is it already 16th? I can't remember. No, 16th. So we have just been in the process of doing a new production for the monthly material. And this really depends on the Copernicus Climate Change Service. sending us, or that we can get data from there once a month for this particular thing. And we do have let's say, developments with the big like global players of forestry, UPM-10, Stora Enso, and then this Finnish middle-sized Metsä Group. And actually Trimble is also a global player, even if they are more known for the kind of the GIS things, or global geospatial information systems, and just finding out where you are. They actually own a lot of forest in Canada, and also are in that sense forestry related. But then the latest thing has really to be bringing machine learning, and especially the soil wetness forecasts have been very much improved. And it would be nice to have a link to the real published, let's say, paper we did on it, but unfortunately it's still in review. They need 2 reviewers. They only have found one, and it's since last Christmas or so that it's been in the system. I guess we need to find some other place to publish. But to get to this trafficability question, so that's what, in a way, the right word for this is it's forest trafficability. And really, it is such a system that in Finland we do have a 16 meter by 16 meter resolution kind of airborne laser scanning based map that tries in 6 classes to already tell where is the terrain that needs winter, where's the terrain that needs dry summer conditions. And that's this trafficability map on the right, where you can say that from the green to the red, we have 6 different classes. And in simplicity, you could say that our service just tries to make that 6-class system be more a 2-class, or in one case, it's a 3-class system. So to simplify that for the end users, with the information that there is in seasonal forecast, and it actually also on weather forecast. So we do have it for the shorter few days ahead way also the same logic applied, and this way of getting from 6 classes for bad, we go to 3 classes, and for the good conditions, either like in winter, when winter is good, then everything can be done everywhere, and the summer good conditions still leave a few areas that have to be red because they are so wet peatlands or kind of swampy in a way, would be a simple explanation, that you only can do them in winter when conditions are good. We have improved since launch because our initial service was just for the Nordic countries, and let's say Fennoscandia and a little bit of Northern Europe in general. Then we expanded to the whole European area. We have added actually forest fire, let's say, information, both observed and forecasted forest fire indexes. This actually we do have both for the European domain and for the Finnish domain in specific from Finnish sources. We also do some, or seasonal forecast always needs something called bias correction or bias adjustment, which we have done over land with ERA 5 land and over sea with ERA 5. The sea is mainly for the purpose that if we only use ERA 5 land, you always have a coastal zone, a kind of where you don't have data. And you do want to help those coastal kind of forest pieces also to be serviced. So we added ERA 5 into this system, and we could achieve something like that. And then the trafficability maps, in a way, have never covered Finland fully because the airborne laser scanning is being done every year a piece more. So we are not yet fully over all of Finland. But in essence, we have then added into the service also something that the snow forecasts don't start out from the wherever the seasonal forecast started from, that it's always the latest observation that we have. So from that, we then kind of let that forecast go onward. So it's more logical in a sense that we already know that the snow is at some level and not higher or lower. So all the forecasts are then corrected to this. And we actually have added at that point the tree cover density. So these are all E-shaped additions. So for example, the tree cover density from the high resolution layers from Copernicus Land Service. That's what we have there. I just checked and remembered we only have the 2018 still in the system, so we actually need to update that one. Yeah. But then trafficability map in the destination Earth action, we actually expanded that to all Europe to have these kind of red zones which would need winter because the kind of peatland or kind of wetland style, let's say, soil or land type is not so common as we have it in Finland. Finland is in Finnish, Suomi. Sua means actually swamp. I'm back again. Oops. That was worrying. I was shortly out. I hope you hear me again. Yeah.
Yes, it's fine. Yeah, you can
Okay.
share the screen. Yeah.
So I have to share again. Yeah. Zack. So, but then let's just, I have to click here. So that was done with machine learning. I don't get into the details, but it's important to have from the Global Land Service, Copernicus Land Monitoring Service, some layers, and then soilgrids.org. The Copernicus digital elevation map is really important here. We calculated from it the topographic wetness index, height, slope, and aspect. And with these, we could really do this machine learning exercise. So, but then one feature that all the end users are always very interested in is actually also the map layers. To have the roads. In Finland, we have very good knowledge of where the ditches are. So all that kind of information is actually also super important when these machines go into the terrain. So it is important that these things are all available in our service. Maybe I don't go into more details on that. But really, the machine learning that improved now significantly in soil wetness. So the most important for the winter, summer case is to how do we understand the soil wetness and also to predict it well. So there's a soil water index, also a Copernicus Land Monitoring Service product. Maybe also here I don't have to go into much details, but in essence, the benefit of this soil water index is that it's not just the surface soil moisture that satellites in a way see, but there's also a rather simple, but it has shown to be quite good, a kind of model that surface soil moistures over several days is a good indicator of what the soil moisture is deeper down. And from this, we get the most interesting and important kind of like layer for this forestry, and the soil bearing capacity is actually more the 7 to 28 centimeter deep soil layer when it is, for example, just the topsoil, 0 to 7 centimeters. So this product is available at 1 kilometer resolution over Europe, so not unfortunately not all over the world. It is a combination of something at 12.5 kilometers that flies on these EUMETSAT METOP satellites. It's the ASCAT, let's say, instrument there. There are actually two different METOPs always in operation. So I think it's pretty much like every hour or even 2 per hour, you get observations from this system. But then to get it, the higher resolution also in there, the Sentinel-1 missions, in essence, at the moment, of course, only Sentinel-1A, because unfortunately the B kind of stopped working 2 years ago. But these both are being combined. They are important that they always see through clouds, so you always have every day or the similar kind, or in the similar rhythm, which is every 6 days nowadays for the Sentinel-1A. Everywhere on this map, you get information on this high resolution, and then when you combine it with the more frequently changing lower resolution material, you have really a 1 kilometer product, which is done daily over Europe. Yeah, unfortunately, no mountains are covered, but mountains, of course, have less soil, so it's also kind of not for some of the mountain pixels, no problem, but in other places, of course, forests are still growing, so we have there an issue, but those are the areas where they usually don't tend to keep very wet. So in that sense, we can accept that. Yeah, but that means that we have been able to really improve much on the soil wetness thing. There's a little bit of this. We use something called extreme gradient boosting as the methodology, or we also tested another gradient boosting methodology. But in essence, we get good results. We really use a lot of different features. So it's both from the soil grids information, but especially from the reanalysis. So what the model gives, that we have inputs. But the most important factor is actually to have the climatology. So over the 8 years or so that we have had measurements of the soil water index, we also made a climatology of that. And this climatology helps to do Europe very well. It is the most important feature. Yeah. And we had to do something like almost 700, let's say, machine learning runs with almost the same data sets. We are using 10,000 points, so you don't need to do all the pixels you have. You can have a subsampling. We tested with 43,000 points, and the results are so little better than with 10,000 that showed us that this works. And we chose specific points in Europe, which are from something called the Lucas. So it's a survey that is done on certain points in the Europe every 2 kilometers from each other. And from those points, we have the land use, we understand. I'm over time already, so I need to go faster. Yeah, but in essence, I don't have to go much into this. This is still cool stuff. Verification shows that we have really improved a lot, and maybe I then just go quickly also into why WEkEO was so great. So we used in WEkEO, and we are also using in the new place we are running it now, like 2 different servers. One to do something called the SmartMet server. That's our own data cube system. Then we have where we get the web map service layers, we get time series for the graphs. And then another development server is the one where we always test and work on new workflows, and then where we can also process stuff. These are all Ubuntu long-term service virtual servers in a way, where we use Conda environments and Docker containers to run this stuff. I think what's interesting maybe for the audience, so on github.com/fmidev, we do have lots of repositories in the Harvest the Seasons site and the Harvest the Seasons SmartMet, and actually also the ML dash Harvest the Seasons. All of them, we have open source all our solutions, so in a way someone can copy and do it somewhere else. Yeah, but it was really great to have this kind of a virtual cloud environment to build our system. And then we have now learned also that we can shift very well this solution to another place. Yeah. And WEkEO is always deployed close to the Copernicus sources. So when we live really on having Copernicus climate change data, mostly, but also from Land Monitoring Service or others, the downloads are very fast there. And that's, I think, a very key element for us to appreciate that. It's not that bad also now in the place we are, but still that's there. And we are actually in a phase where our service will move from the research department that I represent to the commercial arm. And yeah, they will have consider also if WEkEO is maybe the place where they want to deploy it or not. But that's not in my decisions. Thank you for your attention. That's all I have to say. And questions, if there's time.
Thank you very much. So yeah, we have several questions. We will try to answer all of them. So The first one is, do you estimate damage caused by foresting equipment? Does it separate foresting equipment weight and recommend when it's use lightweight equipment when heavy?
So in Finland, we actually do have a law that is saying that how much does this machinery is allowed to penetrate into the forest, let's say, land or soil. So for this definition, they do have to show and be able to show that they didn't like pass this threshold. But then they are, of course, a lot in Finland kind of distinguishing that they do have different ways of having wider tires, flatter tires, and all kinds of tricks to kind of reduce this impact. Or when they ride through that forest area, that when there are small patches that it is too wet, they actually spread out, for example, lesser trees, smaller thing, let's say forest material on top of there to make like a small bridge or a simple float in a way for them. So all of this is happening and interesting, but this level of detail in Finland, it's really done with GIS systems, which have a lot more detailed information, which are actually in these forestry machines. So we don't need to be able to do that part, because then they are already on site and they are kind of doing this. We want to just find where are the days that it's better for your machinery to be moved somewhere and do things, and when not.
Okay, thanks a lot. Okay, the next question is, does the criteria defining good and bad conditions consider forest regeneration capacity and the impact on habitats and breeding of other species?
That is something that we have considered at some point, that we wanted actually to add more the CO2 effect. So in a way, we wanted to expand this understanding of the forestry operators to see how we can help them to make more sustainable forestry in general. And it's more about like how to optimize CO2 kind of like capture from forests. Because this part that you are referring to, so here, habitats and breeding species, in Finland, the maps of this kind of information, where is an area that is kind of like more precious than other areas, they have all of that in the GIS maps, and they are not allowed, or they have to show that they have done the routes in a way that they are not harming these places. So that's not in Finland, not necessary, but it's true that we want to expand and do this in other countries. So in those cases, it might come to the point. But we are more in Sweden at the moment, having some concrete steps to go forward. And also there, I think this kind of other places have this in the maps, and the rules for the operators come from there. So they don't need this in our service.
Okay, I see. Thanks a lot. So next question, can we use the model for monitoring active fires in the forest? Thank you.
Well, active fires in the forest is quite a different topic. We are in other projects doing something like this. So fire propagation modeling we do have, and in a way the same problem of how do you get model data at more kilometer scales to go to this level of 16 meters by 16 or even 10 by 10. I think that's very common and the similar question. But too long an answer to go more deeply than that. Send me an email and we can discuss later.
Okay, thanks a lot. So next question, what thresholds for input parameters did you use to access trafficability conditions in winter, and how did you determine whether the conditions is good or bad? So it's kind of similar to the
but I understand. No, it's more practical in this case.
Yeah.
We have, of course, finished research projects before us who have helped to do that. So in Finland, we have really, by very practical testing, even determined that the frozen soil depth is something 20 centimeters deep, and then even these 40-ton systems, 40,000 kilos systems can go over the soil and it doesn't compact. And for the snow, it's something like 40 centimeters. Snow is difficult in that sense that, of course, if it's dense or light snow, it actually differs. But rule of thumb is there 40 centimeters. And we use these thresholds for the winter case. For the summer case, the research is not as kind of like, convincingly done yet, but and depends a lot on the different soil types. And in Finland, we do have more like two types: mineral soils or these peatlands. That's why in Finland we have an okay information. But this is one of the back kind of like challenges when we go outside of the country, that there you do have more kind of lands with clay and things like that, where we do not necessarily have a good, bad, and good conditions system yet. But there we would really look out for people who are there that want to help us find those thresholds.
Okay, thanks a lot. And so this one, how efficient is the model to understand sustainable harvesting features in dense forest landscape?
Now, our sustainability is really towards the forest soil. And yeah, it is really not simple, because we don't have a lot of real in situ observations that we could kind of like do a proper and scientific validation towards. So we are mostly based on having the really good connections to, like, we have several times have now hundreds of, or a little over 100 different sites where the operators have really done things, and then we have given them the conditions. So that's our basis of understanding our efficiency and how qualitative we are. And we must say that for the summer case, it's still a struggle, because the one time we now did this last year, we had a very wet summer, so there weren't much dry conditions. So when you don't get the scale, so we are actually in the middle of getting this. Still, in event like this next coming summer will help us do it better.
Okay, thanks a lot. So thank you very much for your presentation and the question. We will stop there. For all of the unanswered questions, if you agree, I will ask you to participate for the answer. So
Sure.
Thanks again. And Gerardo, you can start now if you want. And bye, Nico.
Thank you very much.
Okay, good morning, everybody. My name is Gerardo Chirici. I teach forest inventory and remote sensing at University of Florence. I have a forestry background, but I do remote sensing since my PhD, well, more than 20 years ago. Okay, so let's start with some basic information. I will go quite fast because I think this information are well known by this audience, but just to remember that we can manage our forest depending of the different conditions, environmental conditions, social, economic. So we have a kind of gradient between the extreme natural old growth conditions where we try to maintain our biodiversity, to the extreme on the other side of forest plantation that are mainly devoted for food production. So to do so in a sustainable way, we need information, and the information in this moment in most of the countries are coming from national forest inventories. So these information usually to guide forest planning are not coming from remote sensing, but are coming from field observations that sometimes are integrated with Earth observation. This is what I'm going to talk about. So to understand the sustainability of forest management, we use a very traditional approach. There are many indicators for assessing the sustainability, but one of the most used is quite old. It's coming from the 18th century, from von Karlowitz. So the concept is related to the ratio between increment and fellings. So the golden rule of forest planning is that we don't have to harvest more than the increments. Otherwise, we are losing our forest. in the long term. So this is a typical example of the information that we need from forest. So this is what is done in Europe by the Forest Europe, so the former ministerial conference on the protection of forest in Europe that provide information of the ratio between harvesting and felling. So you can see that most of the countries don't cut more than the increment, with some exception where they cut very close to the 100%. So this information are traditionally coming from field observation. So in the past, there was only one way to collect information. That was the so-called compulsory forest inventory. A compulsory forest inventory is based on the concept of census. This means that we collect information on the whole forest. But this is extremely time-consuming and extremely expensive. So more in the modern age of forest inventories, we use the sampling theory. So of course we don't have time here to go in detail, but I think it is important to understand a little bit more regarding the sampling theory to understand how to use Earth observation products in a consistent way. So the sampling theory means that we have our universe. Our universe is the full forest, the whole forest we have in a given country or a given region. So we are not collecting information for the whole forest because this is too expensive, but we are extracting a sample, and the sample must be random, okay? So this is the basic assumption. This is a very famous paper from Horvitz and Thompson, very well known. So nowadays, all the national forest inventories in the world use somehow what we call Horvitz-Thompson estimator. We don't have time to go in details of the Horvitz-Thompson estimators, but just some information that we don't just calculate the estimation of the forest variable, for example, the forest growing stock volume or the basal area, number of trees per hectares, or whatever is the variable that we want to estimate, but we have to calculate the variance. This means that we have to calculate, we have to evaluate the precision of our estimation. So it's what we need for forest planning is not just the estimation itself, but we need an assessment of the error of the estimation. So this is very important for our Earth observation application. Just to understand a little bit better what I mean for calculating the variance of the estimation. For example, this is a very well-known example. So the question here is, what is the area of the purple color? So this is a very strange polygon there, so it's very difficult to calculate the area. So what we can do is to estimate the purple area. To do so, we create a sampling design. Then we put a square grid, for example. This is a way of extracting a random sample, okay? It's a systematic random sampling. So we then calculate the number of plots falling in the purple, and then from we arrive to this ratio. This is the Horvitz-Thompson estimation of the purple area. But what we can do with the Horvitz-Thompson estimator is also calculating the standard error of the estimation. So we have, using this sampling design, we have the 7% of standard error of this estimation. What we can do to increase the estimation, the precision of the estimation, is to create a more dense grid. So I will have more points to calculate the purple color. And so at the end, I have the same estimation, but with a higher precision. So this time I have the 3% of standard error because I have a higher number of points. So this is just to understand you the basic concept of the Horwitz-Thompson estimation that is used also in all the national forest inventories. Of course, the sampling design, the methods are more complicated, but the basic concept of the sampling is the same. So please remember, we don't need only the estimation of the variable, but we need also the assessment of the uncertainty of the estimation. So let's go now to the Earth observation component. So we all know that we have a lot of products coming from the Copernicus system, especially the Sentinel-2. The Sentinel-2 satellites are providing a very rich time series of observation, but we have many other satellites. The Sentinel-2 is collecting, for example, well, this is old already because this is with the constellation of 2 satellites. We know now that we have 3 satellites, and so we have an even more frequent acquisition of this data at 10 meters resolution. So a lot of data available for our application. So what we have to do now is to have an infrastructure for elaborating all this data. So this is where WEkEO is coming for helping us. So in the past, we had a lot of approaches, but in the different countries, of combination between the national forest inventories and the Earth observation to create wall-to-wall maps of forest variables. So at the end, we need 2 sets of data, 2 types of data, the data coming from the remote sensing platform and the data coming from the field observation, from the sampling design of the National Forest Inventory to create wall-to-wall maps. How to do this? We had I would like to put here some for those who are interested in having more information. I have some papers related on this kind of application. So we have a number of different techniques for combining Earth observation and data. So you can see different methods where we can combine satellite data with field observation, or we can also combine Earth observation coming from multiple sources, also from drones, for example, that are sometimes acquired also with the sampling design. So a very large number of possible methods, but more or less coming all from the same concept. So here, an example from Italy. I work in the team of the National Forest Inventory in Italy to create maps of the forest variables that we collect in the field. So here you can see our field observation coming from 7,000 plots acquired on the basis of the sampling design. On the left, you can see the dots that are colored on the basis of the growing stock volume, and on the right, on the basis of forest types. So Italy is a quite complex situation because of the latitude, because of the distance from the sea, because of the orography. We have a lot of different ecological conditions, so a lot of species, a lot of tree species, a lot of different types of forest management. So it's a quite complex condition. So here are some example of the data that we need. As a starting point, we need a no-forest mask. This is a tricky point because the forest mask must be developed with the same definition of the forest definition that is used in the National Forest Inventory. So in Italy, we use the FAO definition, so half an hectare, 10% of cloud coverage, and 5 meters height of the trees. So the forest mask coming from the remote sensing must be consistent with the same forest definition that we use in the field. So then we need the predictors. Okay, so the input data that we use for creating the models. So for example, this is from Sentinel-2, from Sentinel-1, and then at the end this is a point where we can use the WEkEO system. So we can use different methods for Italy. For this application, we use R as a way for a simple code for acquiring the data from the Copernicus platforms. The system that we use is a CART, is a classification and regression tree. We don't have time to go in details, but you have the slides where you can go through the methods. The methods is very well known. The algorithm is the random forest from Rayman. So it's a very well known ensemble learning model that is used to predict the variable on the basis of the predictors. It is important to include in the predictors also the harmonic metrics that we can calculate from the very dense time series coming from Sentinel-2 imagery. So this is a very important variables that we can include in the model. Of course, we have to evaluate the different models that we can try to set up, so to optimize the models. And this performance evaluation is carried out on the basis of the sampling data that we use to create the model. But in order to avoid the overfitting, we use the leave one out cross-validation procedure. Once again, we don't have the time to enter in details, but it is very important to remember that to do this operation, we cannot exactly use the same data that we used for creating the model, but we need some kind of procedure for splitting the data. So this is very important. But at the end, when we are happy of the model, then we can run the model, and then we have the wall-to-wall map of the forest variable that we want to create. And this is an example of the growing stock volume map that we created. This is also published already. So we have some papers where we describe this procedure in details. And these are just some nice maps of the growing stock volume map that we created for Italy. As you can see, it is masked on the forest non-forest mask. The point is, and you can see the point of the national forest inventories over there. But now, what we can do with this data? So why we create the map of the forest variable? It is important to remember that this is not something from me, but there is a consensus in the community of the people doing remote sensing with National Forest Inventory. Please avoid the use of the maps at single pixel. So because the specific pixel of the prediction of the map can have consistent error. But if we aggregate some pixels in what we call usually small area estimation or model assisted estimation, then we can have a very good estimation for a small area that we call usually forest unit. A forest unit that can be used also for forest management. So you can see here in this picture our growing stock volume map, and overlaying with forest management units. So you can see you can extract the statistics from the pixel for each forest management unit. just on the basis of the national forest inventory. So what we can see what we can say is that Earth observation can be considered a kind of bridge between the national forest inventory, that is something that was originally designed for forest planning, for large region estimation, down to the small area estimation that is needed for forest management. So in this moment, we are not using yet the cloud computing infrastructure that is offered by WEkEO. We are using a different cloud infrastructure, but for the future, we hope to be able to use this WEkEO cloud computing infrastructure. Thank you.
Thank you very much, Gerardo, for your nice presentation. So we will move on to the Q&A. So the first one is about which algorithm is best for land use and land cover classification based on the current evidence.
This is a tricky question in the sense that algorithm should be adapted to the local conditions. So it's difficult to say an optimal algorithm for everywhere. So what we do in a research activity is to try different algorithms to see if they work, which one work better depending on the predictors we are going to use and the condition of the forest area. It's also important to remember that sometimes we use this ensemble approach. So we are not just using one model, what we use the prediction from different models, and then we vote the different methods. So this is a method that can be used also for land use, land cover classification.
Okay, thanks a lot. So this question, I've been hearing forest all the time. What is the definition we stand by here? Are green places in cities or unused lands covered by vegetation considered?
Okay, the official forest definition that we agree that international level is coming from the FAO, coming from a very long discussion on forest definition. So now we agreed on the forest definition that exclude the forest in agriculture and urban areas. But this is something that we can do with remote sensing. I mean, even if official statistics of forest are not taking into consideration this area, you may be interested in estimating, for example, ecosystem services in urban forest. So there is not problem to expand the estimation also in these areas. So there is no technical problem in expanding in other green areas, but that are not considered officially forest according to the FAO definition.
Okay. So, and we also have this question about what does Italy define as forest area, height of trees and canopy cover. So I guess you used the general definition, obviously. Yeah.
Yes. The official definition of FAO, that is also the definition we use in the National Forest Inventory in Italy, is half an hectare, so a minimum size of half an hectare with a 10% of tree cover, and the trees are those that are able to reach the 5 meters height at maturity. So this is the official definition of FAO.
Okay, thanks. This question about if you are incorporating seasonal variations in your dataset when training the RF model. If so, does it have a positive impact on the performance?
Yes. Traditionally, we don't use this information in this kind of estimation. So we are just taking the data from Earth observation coming from the top seasonal condition that typically in Italy is around June, something like that. But it's true that nowadays we have more data available. For example, from WEkEO, we accessed this phenology the data set. So we are now developing a new, we are trying to incorporate phenology also in this modeling. For the moment, we are not achieving very strong changes in our estimation, but it's something that we still have to work on.
Okay, I see. Thanks a lot. This question about how do you incorporate forest disturbance mapping? Is it the subtraction of two forest cover maps, or are you able to calculate it directly from your model?
Yes, is the second. I mean, we incorporate this trajectory maps, the temporal trajectory maps. Well, the temporal trajectory indicators, variables that are calculated through these methods as predictor of our estimation. So there is another problem that is related to the that we have to be consistent in the time series of these maps, because every national forest inventory is updated regularly, and so also the maps have to be updated regularly, and we have to take into consideration that the data must be consistent also in the maps. So this is a problem that, but there are several techniques to solve this problem, yeah, for the moment, we incorporate the temporal trajectory as predictors.
Okay, thanks. This question about if the forest inventory is done in Italia or whole of Europe. Also, I see some missing inventory on a small island in Sardinia. So I don't know if you know that, I guess.
Okay, I don't know which small area is from Sardinia, because this is depending just of the forest mask. So we can do the estimation wherever we want. We just need the forest non-forest mask. But regarding the whole Europe, this is an interesting question, because the problem is that we don't have a pan-European data set of national forest inventories yet. I mean, this was done in some research projects, for example, the Joint Research Center of ISPRA. They collected and harmonized a large data set of national forest inventories across Europe to create a forest biomass map of Europe. You can download from the Joint Research Center website. But that was done for a specific project, so it's not regularly updated yet. So yes, the problem of creating a consistent pan-European mapping of forest variables is still active. There are several research projects working on this. So I hope that in the coming years, we will finally have this kind of pan-European products, but for the moment, it is not available. It's not. I don't think we will have it in a couple of years. I mean, we will have more times, because national forest inventories are difficult to be standardized because they are very different in the different countries.
Okay, I see. Thanks a lot. Okay, so we have time for a few more questions. So what is the best algorithm for forest phenology, and which remote sensing data will be best for deciduous forest? So
for the moment, the best variables are coming from the Sentinel-2 data set, because we have 3 satellites on the same orbit, so we have very frequent observation, and the resolution of 10 meters is good enough for this. And regarding spectral trajectory, I think you can give a look to our slides. We have some reference so you can pick the methods from the papers.
Okay, thanks. Okay, one of the questions is about today's presentation on downgraded models to pure Sentinel, WEkEO, and open data sets, or is it still commercial data sets that are used? So you used WEkEO data?
No, we use just Copernicus open data set. We didn't use any commercial data for this application.
Yeah. Okay. Okay, I think we have time for 2 more questions. So can you use, I guess, the models in predicting the regenerative status or capacity of the forest to sequester CO2?
This is a difficult question in the sense that we can we can map all whatever is the variable that is measured in the field. So if you measure something, then we can try to estimate with remote sensing. So this is the basic concept. Then on the basis of the map that we provide, then we can create other models that can simulate the carbon cycle, for example, like biogeochemical modeling. So it's not directly these methods that create this kind of fluxes, but our data can be an input for biogeochemical modeling that do this job of calculating the fluxes.
Okay, okay, thanks. And so I think it will be the last question about how to differentiate the forests which are covered under snow to the normal ones. I guess you have flagged.
Yes, this is a basic pre-elaboration. This is part of the basic pre-elaboration step. When we do cloud removals, because the main problem is removing the clouds, then we also have to remove the area covered by snow, and that are replaced by clean pixels. There are several methods. Now we use this best available pixel approach, but it is also true that clouds and snow are easy to be detected by optical remote sensing. So it is a basic pre-elaboration step that we do.
Okay, thanks a lot. And so this one will be the last question. So did you consider super resolution on Sentinel-2? I guess it depends on the area you study, maybe?
Yes, our maps at the end are produced at 23-meter resolution, even if we have a higher resolution in the input data, because the 23-meter resolution mimic the area of the sampling plot used to measure the variable in the field. So this is also something that is coming from literature from 20 years ago. There is no reason for creating maps at a higher resolution than what we measure in the field. Okay, even if technically it is possible, under a statistical point of view, is nonsense. So we have to create maps of the same resolution of the sampling unit we use in the field.
Yeah, it's true. Good remark. Thanks a lot. So I think it will be all for today. We have still some unanswered questions, but more general, so it will be done in the post-event report. But yeah, thanks a lot, Gerardo, for your nice presentation and the question. So, okay, so again, thanks a lot to everyone for the different presentation and the Q&A session. So we are now reaching the end of today's session, so I hope you enjoy it and you were able to answer all kinds of questions. Before you leave, I just want to remind you that there is a section next to the Q&A, which is reserved for the polls. So we would really like to have your feedback on today and what we could provide in the future. So if you could please take 2 minutes of your time to answer some of the questions. If you assist to the second day, you will be able to add some remarks and notes. Again, don't worry about that. And also, as you know, in 2 days, we will have the practical session, so the day after tomorrow, Friday. If you haven't had time yet, I invite you to check the full tutorials to get ready for it. So these tutorials are available in full. You have a 1-hour explanatory video, with the documentation and all of the scripts and data you might need to run the tutorials. So as you can see, there is a tab on the top where you can find the Jupyter, QGIS, and RStudio section, all of them using Copernicus WEkEO data. And then on so in 2 days, on Friday, we will have the summary presentation of these tutorials, and our experts will be there to answer your questions. So we hope you are there as well. So I guess, yeah, thank you to all of our speakers, and for the participants, see you in 2 days' time. Bye.